Hi, everybody. Welcome to our online workshop introducing the cesR package developed by Rohan Alexander of the University of Toronto and Paul Hodgetts of the Toronto Data Lab. My name is Simon Kiss, and I am an associate professor of digital media and journalism at Wilfrid Laurier University and the new director of the Laurier Institute for the Study of Public Opinion and Policy. LISPOP has a broad mandate supported by Laurier's Office of Research Services to facilitate research and communication in the field of public opinion. And one of my goals as the new director of LISPOP are particularly because of the way in which it can improve reproducibility in social scientific research. So I was extremely happy to hear about the release of cesR because I think it's really going to be path-breaking in that it's going to dramatically reduce the costs for researchers in and outside the academy to plumb the depths of Canadian history since 1955 via the Canadian election studies. So I'm very happy to have partnered with the Consortium on Electoral Democracy, which is the group charged with running the current iterations of the Canada Election Study, based at, I guess, 4 universities, UDM, I think, Western, Ryerson, and U of T. And they helped to co-sponsor the event and distribute and spread the word about it. So thanks to them. So first, Paul Hodgetts is going to give us a tour of cesR, and then Rohan is going to give a presentation on Open Data Toronto and reasons for reproducible research. And then we'll have time for some questions, which I'll try to take via the chat. So with that, I'm going to turn this over to Paul Hodgetts and then to Rohan. So thank you for joining us.
Thank you. I'm just going to get the slideshow started. Multiple monitors makes things difficult and easy at the same time. Okay. So hello, everyone. My name is Paul Hodgetts, and I'm going to be presenting on the cesR package that Dr. Alexander and I created this past summer. The purpose of this package was to improve access to and working with Canadian election study survey datasets. And in addition to this presentation, I will also be providing a demo of the use of cesR in R. So just to get a bit of an overview, the Canadian Election Study is a series of large-scale surveys conducted every Canadian election year. These surveys seek to provide a retrospective insight into various election-related topics, such as voter intention, importance of election issues, and perception of political parties and candidates. The first CS survey was conducted in 1965, with the most recent having been conducted in 2019. And lastly, CS surveys are publicly available from various repositories across the internet. The idea for cesR came from various areas. First, that accessing data is crucial for performing quality research. There have been countless times that I personally have been frustrated because data was either difficult to locate or inaccessible. Second, there are a plethora of R packages that provide direct access to data, packages like Open Data Toronto and Layman's Baseball Package. The utility of these packages is great, and they provide various benefits, such as providing direct access to data without the need to set a working directory, and this makes working with data in R more efficient and working between computers much easier. Packages such as these also provide opportunities to include tools that improve the process of working with the data, as well as making the process a little more reproducible. And lastly, the Canadian Election Study was specifically chosen for this project because of its utility regarding multi-level regression with post-stratification and other analyses. So an R package should improve the experience of working with an R. The first build of cesR only included the 2019 CES data and had that data built directly into the package. So when someone installed the package, the data was installed alongside. However, this design created issues when other CES years were included, as it made the package quite large. This also raised a point that I have been unaware of. I do my work on a quite powerful desktop that I built and is quite capable of handling most tasks easily. It wasn't until Dr. Alexander pointed out that the package was taking a while to download and install that I realized there was a problem with the design. This informed the design of cesR to ensure that people beyond myself would be capable of using it. The goals of cesR were then to provide access to CES data, keep cesR as small as possible, and minimize the number of steps needed to load CES data into R, as well as provide tools to assist in the use of cesR and CES data. So following these goals, cesR has 5 included functions. The first of these functions is the getCES function. Instead of building the CES data into the package, cesR was designed to use these functions to download a requested CES survey. The getCES function works such that it takes one argument in the form of a character string. This argument downloads the associated survey, creates a data object from the survey, removes any downloaded files, and then prints out the associated citation UR link to the repository. In keeping with the goals of keeping cesR as small as possible and minimizing the number of steps needed to load CES data, by creating a data object in the global environment and then removing the download files, getCES minimizes the number of steps to access CES data to one line of code, while also minimizing the overall size of cesR by completely excluding the storage of data files. getCES is also written in such a way that a dataset can be loaded more than once just in case a fresh version is required. To be able to get a CES survey with the getCES function, you need a survey argument code. The getCES codes provides these for you. It's a fairly simple function. It constructs a data frame from 2 vectors, which are the survey codes and the character string arguments, and then prints that out to the console. It includes both the code and the arguments so that someone could just copy and paste from the table. It's a nice simple function with nothing overly complicated. And there may also be a situation in which you may not immediately want to load a complete data set. For instance, if you just want to get an idea of how a particular year's data set is structured. For these situations, cesR comes with the getPreview function, which takes 2 arguments, a character string CES survey code call, the same as those used with the getCES function, and a numeric value for the number of rows to be returned. If no value is provided for this second argument, then the function just defaults to 6 rows to be returned. And the next supportive function is the getQuestion function. This function takes 2 character string arguments, one a data object name and the other a column name, and prints out the variable label associated with that column. In the case of the CES survey datasets, that is the survey questions for that variable. There are 2 important characteristics of this function. The first is that it takes 2 character string arguments, and the second is that this function can actually be used outside the cesR package. The function is written in such a way that it will actually return the variable label for any given data object column combo if that data object is of the type labeled. I'll also be demonstrating all these functions after this presentation. And the last function is the getDeacon function, which creates a subset of the 2019 CES online survey dataset under the name Deacon. This name stands for Demographics and Economics, which are the 2 types of survey questions included in this dataset. The code for this function is similar to how the getCES function works in that no files are permanently stored on the computer after downloading. The main difference between the getDeacon function and the getCES function is that getDeacon checks if the object named Deacon exists, whereas the getCES function checks if a file exists. This means that the Deacon dataset cannot be reloaded without removing the data object first, whereas the CES data can be called more than once. The reason for including getDeacon is that it provides a tool to assist educators in the instruction of statistical analysis, and it is a robust data set to which various methods of analysis can be applied. As well, it can be used to instruct in data selection, cleaning, and manipulation given the variety of variables. So currently, cesR is heavily dependent upon other R packages such as Labeled and Haven to read in the CES survey datasets. So far, this hasn't been an issue, but any changes to these packages could change the functionality of cesR. So one step for future direction would be to move away from this dependency. Additionally, cesR currently downloads the survey datasets from an associated GitHub repository. This was done for the reason of simplicity. Future step is to shift the URLs used to download the surveys to the data repositories holding the survey datasets. And lastly, the CES surveys have sections that are of similar topics, i.e. economy and democracy. Future step would be to build a function that automatically creates subsets of these topics. And to finish off this presentation, all the code for cesR is available on my GitHub under the cesR repository. My username is Hodgetts P. This repository also includes a README on using cesR, and cesR is also available for install using the DevTools install GitHub code shown here, which I'll also demonstrate in a minute. If you do end up using cesR, testing and feedback is very appreciated, and you can reach out to me using any of the email addresses listed here. So I'm just going to close the presentation down and move over to demonstration. Can people see this okay?
I've got your desktop.
You got the desktop? Let me see. I'm just gonna switch screens. Yes, I was on a different monitor. Is the code visible?
Yeah, I've got cesR examples. Yeah.
Okay. I just want to make sure that it's readable as well, just because it might be smaller. I don't want, and the theme I have set may be difficult to read, but.
I think the theme's okay, but maybe just maybe zoom in just slightly. Usually
Sure.
students, yeah.
Okay. So to install cesR, currently because it's not on the CRAN network, you have to use the DevTools install GitHub. This force equals true isn't necessary for a first-time install. I just have it because I already have cesR installed, and I want to show there's a particular line that comes up in the console during the installation that I want to show. So just running that, you can see over here that it's downloading, and then there's this enter one or more numbers or an empty line to skip updates. You can just hit enter there, and that will continue the installation. And that's installed. And just to load cesR into R, it's the same as loading any other package into the R workspace, which just uses the library function and then the package name. So just doing that loads it in, and it's available now. And so first off, I'm going to use the getcs code so that I can see what are the codes that I could use to call a CES survey. And when I call that, this is what it prints out here. And I'll also actually show you if you were using it in the console, it prints out this way. So the difference being is that in the R Markdown workspace, it truncates, but you can just switch between, and then in the console, it prints out the whole thing. And so for this one, I'm going to use the get preview, and I just want to see the 2011 survey, and I'm going to set that to return 10 rows as a preview. And you can see over here it's running, and then once it's loaded up here in the environment, I got a CES 2011 preview. And if I want to take a look at that, I can use the head function from R. And this second number here sets the number of rows to be returned for the head function, which then prints it out down here. And it's nice, and you can see effectively what the data set kind of looks like, what you can expect in terms of variables. And just to give an example of if you don't use a number to set the number of rows, I'm just going to call the 2004 survey with the get preview. And there you can see that it's returned 6 rows by default, which shows up here in the number of observations. And I'm just going to remove those just so that they are, there's no confusion in what's going on. So in the next one that I'm going to use is the main function is getCES. So this calls the whole survey. I'm just going to use the 2004 survey. And you may have noticed a quick flash on the screen. It will be slower depending on your internet. That just shows the progress bar. That's something that I actually just added in recently because I found a nice visual feedback for how long it's taking to load in a data set. It's nice to know. But I have an Ethernet cable running into my desktop, so it runs nice and fast. So after the survey is loaded, it comes up here automatically under the same call name, and it prints out the citation right here, as well as a link to the actual location in the repository. And then you can check again just to see what the data kind of looks like. And then for this one, it's the get question. So if I was curious about a specific question in the survey and I knew the column name, so these column names that are used here in the second variable or in the second argument, they'll vary from survey to survey. But if I knew the actual column name, I can just use that there, and I'll do that, and it tells me what question that was for that survey. So for CPS C1 for the 2000 survey, it was, during this campaign, have you been contacted by a political party by phone? And the next function I'm going to load in is the get deacon, which is the pre-created subset of the 2019 web survey. So this one I haven't set to show the progress, and I'm actually going to push that update today. So you can see, without that progress bar, you kind of left wondering what it's doing, which then it loads out the same, it loads out the citation for this, for the 2019 online survey. And then just using the head function, I can see again the columns that have been loaded, and see that the table has already been converted to factor, which I have set the deacon function to do. Now, what you may notice is, while they are different surveys, you may notice that in the 2004 survey that the provinces are still listed as codes, and in the deacon one that they are listed as the actual province name. That's because the get deacon function, as I said, automatically converts the data set to factor type, and the get cesR I've left just to download as the raw data, so I don't interfere with anybody's workflow, because they may wish to have the codes as opposed to the actual names. But if you do want to convert the data set to a factor type in a quick way, the label package is a great resource, and I'll just demonstrate that here. So installing it, this comes up because cesR has the labeled package built into it, and it's because it uses functions from the label package. So I'm just click no, I don't need to restart. And then I'm going to use the library function again to just load in the package. And then I'm going to use the two-factor from the label package, and that will create a CS 2004 factor. And you can see here now that the provinces are coded. And that's really the main functionality of cesR. And that'll be the demo, and I'm going to pass it off to Rohan now.
Thank you, Paul. I'm not sure where Dr. Alexander came from. I'm Rohan, and I'm Australian, so we just go by first names in Australia. It was a real thrill working with Paul on this. He did all of the work, but one of the great things about being an assistant professor is you get to put your name on things. So. I'm just having a look at the audience. I see a lot of folks that are sort of political science interests, have political science interests. And so one of the things, once we have this sort of political science data that we might get from cesR or the CES, we might like to explain it with some other sort of data sets. And so I wanted to go through an example of one data set that you might be interested in, which is the Open Data Toronto data set. After that, I wanted to go through a slightly more fun data set, which is grabbing some data from Spotify, just to try and inspire you to stick with R. We've got one of the PIs of the CES, Laura here. She mentioned she's not quite into R yet, so hopefully the ability to download data from Spotify will inspire you to stick with it. And then finally, I just wanted to talk a little bit more about why we might like to use R, RStudio, and some next steps if you have been interested. I'll just put a link to all of the code that I'm going to use into the chat so that it's there, and then share my screen. Okay, Paul, have you got the slides coming up for you? Yeah. Yep. So Open Data Toronto it's a wrapper. So the City of Toronto has a whole bunch of data that they've made available, and that is really nice. And what Open Data Toronto does is it makes it easy for you to get that data into R. It was developed by Charlotte Gelfand, who is based in Toronto. And it is available on CRAN. And so Paul sort of mentioned the difference, the CRAN and GitHub installation in the terms of cesR. And I'll talk a little bit more about that in a moment. But essentially, what it means is that if you want to use this data, this package, all you have to do is install.packages and then Open Data Toronto. Just a quick note on the language that is used in the package. So data sets are packages. So bus time tables, homeless numbers, which is going to be the specific example. And so they're packages of resources. And so there's various CSVs, Excel, there's a whole bunch of different actual items within these packages. So there's resources within packages. So that's the language. Okay, so I'm just going to go through an example of live coding, how we might use this. And the data is, I put it in the chat in case I make mistakes. Okay, so can you see the,
Yep.
Yeah, okay. I'll just pull out the chat just in case anybody is making comments. I'll be able to see them in the chat. So the first thing that we might like to do is we might like to install the package. And so, as I said, and I'll get into more about what this actually means, it is available on CRAN. And so we're going Open Data Toronto, and we'll run that. For those of you who are new to this, what I'm doing is I'm just highlighting this code, and then on my Mac, I'm hitting Command Return, and that executes the highlighted code. I'm within an R file. In my case, this is saying, well, you've already loaded this package. So in your case, if you're new to this, it's not going to say this. I'll just say cancel for now, but that's going to go and grab that. Once we've installed a package, we need to use it. And the analogy here is between a light bulb. Okay, so I've just moved house. And if you want light in a room, you have to first, screw in a light bulb into the socket. And so that's what we're doing when we're installing .packages, where we're screwing the light bulb into the socket. The next step, and this is going to be the library, and you saw some of these with Paul, is when you're actually flipping the switch. So you flip the switch, you get light. And so the very first time you move into a house, you need to go and put in all the light bulbs. And that's the same with install packages. You only need to do that once, but every single time you need light, you need to call library, okay? And so I'm just going to I'm just going to use library Open Data Toronto because that's the one we're interested in. I'm not going to spend too much time on tidyverse and lubridate, because the focus is very much in terms of grabbing data sets of this talk. But there's a lot more I put in the notes, telling stories with data, there's a lot more on those packages there. So I won't worry too much about those. All they're doing is making it easier to work with R. And so again, I'm just highlighting those, and on my Mac, I'm hitting command return to turn on the light switch, as it were. Okay, so we need to go and get data. And so what the next, so we're going to end up with this code. And so what we're doing is we are searching through the packages. And so I'll pull up what this looks like on the Open Data Toronto, because I said that Open Data Toronto, the package is a wrapper. It's a wrapper around the City of Toronto's Open Data Portal. And so in the same way that we can search for data sets here, so let's see, homelessness, homeless, maybe. In the same way that we can search for data here, we can also search for data within the Open Data Toronto package, okay? And so the one that we're interested in is daily shelter occupancy. Now, oh gosh, it's been a while since I've used Stata. I forget what the assign is, but the arrow here is assign in R. And so we're going to grab some data and then we're going to assign it to a thing called all data. So we'll just go and get started with that. And so this arrow, so whatever we're putting on the right of this arrow over here is going to be called something called all data, and it's going to show up in our environment here. This was something, again, that you could see with the cesR example. If you've got any questions, just put it into the chat. I've been teaching undergraduates in the fall, so I'm used to the questions. If anyone has any questions, feel free to jump in. So we're going to use these two data sets, functions. And so in the same way that, for instance, we had, Paul gave us get deacon, we've got search packages. And this language here, you can see we've got the Open Data Toronto and then : : That's just saying from the package Open Data Toronto, we want to search packages. If you forgot what goes into a particular function in R, then you can put a question mark around it. I'll just make this a little bit bigger. You can put a question mark around it and then execute it. So again, I'm just highlighting that and hitting, oh golly, and then hitting command return. And it comes up in this help pane. And from this, you can see that this search package, it takes a title, which is something that we're going to search, and the number of packages that we're going to search. So in this case, we're going to search for daily shelter occupancy, and we're going to ask it to list our resources. And remembering from our language, our resources are going to be what's within the packages. Okay, so if I just return that, I just execute that, it shows up in the console, as Paul was showing us some examples of this. It doesn't show up it's not being assigned to anything because I'm not actually running this. But in this case, if we run this whole thing, then we're going to get a new object up here in the environment. It's going to be called all data. And we can see that we've got a whole bunch of resources here. I'm going to be interested in the CSVs. And so I'm going to have to select those ones and then go and grab them. And what I need is these IDs, actually. Those of you who are familiar with Stata, one thing that we can do is we can actually overwrite names. And so if I was to, and I'm not going to focus too much on the dplyr content here. That's from the tidyverse. But if I was to run this all again, then it would just overwrite. don't totally get this. You can see actually we've got an example of a comment here. So in R, comments begin with the pounds. What do you call it in Canada? Is it hashtags, pounds? Hashtags. So you can comment a line, and so if I was to start a comment here, then the whole line would be commented. So typically I try to put some comments at the top about what the package, what the script is doing. Okay, we're coming up on half past, so we might try and keep it moving. Well, I'll skip this and I'll move to making a graph. Okay, so we're just going to execute this. We've got this data now, and we've ended up with around about 150,000 observations, so rows in our data frame. And so for every homeless shelter in Toronto, for every single day, we now have a number for how many people, how many beds were occupied and what was their capacity. So this first row, this is Costi Immigrant Services. We've got a location. It's a co-ed facility, and they were fully occupied on the night of the 1st of the year of 2017. This next one, they had 13 people in there, and they had a capacity of 17, and that was a men's shelter. So we've got 150,000 rows of data here. Number signs. Scott, could you just expand a little bit on what you're...
Oh, you're just asking about what we call the pound sign, sorry.
Oh, beg your pardon. Thank you. Yeah. Okay, I won't focus on... So what I'm doing at this point is I'm cleaning the data. So if we have a look, for instance, at the date, it's fairly messy. There's also some inconsistencies here. I won't focus on this too much because I want to get to building some graphs with that. But the code is fully available at that GitHub repo. So I'll just copy and paste that in. We're not going to worry too much about that. So one of the lovely things about R is that we have a thing called Ggplot. It's actually Ggplot 2, but for most people, they weren't around when there was Ggplot 1. So they just refer to it as Ggplot. And what this is doing is GG stands for grammar of graphics. And it's trying to say, well, there are fundamentals of graphics that are consistent whether you're making a line graph, a bar chart, a point, the scatter plots. They're consistent. And so we're going to rely on this grammar. And so one of these things we're about to use is Ggplot. What I'm doing here is I'm going to try to create, for every day, I want to know a usage rate. So what was, we were seeing the data before. So what was the occupancy divided by the capacity? So if all of the beds were used, we'd expect this to be 1. If none of the beds were being used, we'd expect this to be 0. And so I'm just creating some usage rates by day, by type. So is it a men's shelter? Is it a women's shelter? And so now we're going to make this, we're going to make a graph here. And actually I will write this one out. Because it's interesting. And so we've got our data, which is our usage rate. We're going to, first we call Ggplot. And so that's the function that we're going to use. And so in this first line, we're going to say anything that's consistent between any other types of graphs that we'd like to use. So something that might be consistent is what we have on the x-axis. Doesn't matter whether it's a bar chart, scatter plot, doesn't matter. So we might like to put that in. And we put that in with an aesthetic. So AES is standing for aesthetic, and that's saying on the x-axis, we want the date. On the y-axis, we'd like this usage, which is this percentage that proportion that we've created, and we'd like to color it by sector, which is, was it a men's shelter? Was it a co-ed shelter? And so if we would just run this, and it pops up here in our plot view, we just get an empty graph, but the fundamentals are there. And so now on top of this, we can add a layer. And so GG, the grammar of graphics, is all about layers. So we can add a layer. And in this case, we might like to add a point chart. And so if I didn't know what the arguments were, I could just hit question mark and then execute, Command Shift, and it's going to come up in this help viewer. And we're just going to, but for now, I'll just run this. And so highlighting it, oops, need to get rid of the question mark. And it's going to show up in this plot. And oh, I gave the game away. I forgot to do the filter. Oh, how annoying. And so I'll just make this a little bit bigger. And so on the x-axis, beg your pardon, on the y-axis, we've got the usage. So this is a value between 0 and 1. And you can see that for a lot of the time, we do have very high usage rates of homeless shelters in Toronto. They're colored by the type. And so the red, for instance, is our co-ed shelters. The blue is women's shelters. And we may think that up to 2020, we have, okay, we've just got a capacity problem. What we need is just more beds, perhaps, as in homeless beds in Toronto. And then, of course, COVID hits and usage rates plummet. And so maybe actually what we need at the moment is a lot more beds because they are perhaps the homeless, perhaps, I don't know, perhaps they don't want to be within shelters with other people. They're worried about getting COVID or some other sort of thing. And the question is, well, where have they gone? I know some of us on this call do live in Toronto, so you may have, I think a lot of them have gone to parks, and now the government is trying to make it illegal to go in parks. And so one of the things that I love about data analysis of this type, and it's a quote from Kieran Healy, and it's that, so I was just able to get 150,000 data points just like that, right? Very little effort. You could do it as well. There's nothing to stop you. And what it allows us to do is some people think that the numbers sort of hide the story. And I think that for us, this sort of graph I think it just really shows how horrifying the lives of these homeless people are normally, but especially during COVID, because what has made them leave it? And so that's what I really love about this graph, about working with data. And there's a whole bunch of different data sets in the Open Data Toronto package. How are we going with time? With 25 minutes. I might do something a little bit more lighthearted, a little bit more fun. So Spotify. So Spotify has an API. Could I ask, do most people use, Paul, could you run a poll and we just see who actually uses Spotify? Or, I mean, you could just put it in the chat or something like that. Do people use Spotify? So Spotify runs an API, and what an API is it is a way of companies or anybody to set up a computer such that another computer can get the data. And that's really all an API is. And so Spotify have set up their computers so that my computer can go to their computers and get data. What the SpotifyR package does, and you might be noticing a bit of a joke amongst R developers in terms of just adding R to the end of things, cesR, SpotifyR. What SpotifyR does is it wraps around that API and it makes it really easy to use. So we're going to be able to use it with very little code. Now, this one is on CRAN and on GitHub. So our first example, cesR, by Paul, largely, that's on GitHub. The second example, Open Data Toronto by Shala, that is on CRAN. And so SpotifyR is on CRAN and GitHub. And so I've just included the code here. And again, if you're interested in following along with the notes in more detail, the notes that I'm following here are the Telling Stories with Data link from before. Now you do have to register as a developer, but that's completely free and very easy. All it requires is that you have a Spotify account. So if you've used Spotify before, then you can register as a developer. And what we need is to tell Spotify that, hey, this is my computer and you can give me some data so we can beg your pardon, I'll put this link, sorry. I'll put this link in the chat. And so you go to their developer site, we log in, it's doing it automatically just because I just practiced it before. So but you just put in your regular Spotify account and we're going to create an app. So going up here, and we need an app name. So we can have talk demo, just an example. And what it's asking here is just to confirm that we're not using this commercially, and we're certainly not using this commercially at this point. What you need from this, and I appreciate that the black background is slightly difficult for you to follow. I'll just zoom in a little bit. What you need is this client ID And then what you want to do, and I won't do it here, but what you want to do is you want to click on this show client secret and you want to grab that as well. So you need this client ID and you need to click on client secret and then copy that as well. So for now, I'll just copy the client ID and then I'll shift this off screen and copy the client secret. Not that I don't trust you, but I don't trust the whole of YouTube. Okay. Yeah, thanks, Paul. I think that's the way to do it. Okay, so just, oopsies, copying the client ID and the client secret. Okay. And so what we need to do is we need to, yeah, I agree. What we need to do is we need to tell, I'm just creating a new R script here. We need to tell R to use these secrets. And so the notes that I'm following here are, oh gosh, are here. Okay, so we've done all of this content. We've done all, oh no, Laura, I spent this whole time trying to convince you to use R and it's all for nothing. So we've done all of this. We've gone and grabbed we've created our things. And what we need to do is we need to sort of save our secrets somehow, okay? And so R has this built in. And so we're going to use this, and what we're going to do is it just allows us to manage secrets. So again, I'm going to paste this. I'm not going to execute this on screen for you because that's going to come up with all of my secrets. But what happens is you highlight this, you execute it, and it comes up with a file. And I'll just do that off screen and then drag it back so that we can see what it looks like. Okay, so it comes up with this R environment file and it's empty. And what you do is you paste your, and I can paste the other one. I can, we paste this in. Now, if I just paste it in like that, that's what I copied from Spotify. That's not going to work exactly like that. So what we need to do is we need to tell R what this thing is. And in this case, it is the Spotify client ID. And we just wrap that in quotes so that it knows that it's a string. Don't worry too much about what these things mean if you're new to this, but we're wrapping this in quotes so that we know. And then on the next line, we're going to copy and paste exactly the same thing, but for our secret. And so that was that line that I didn't show you. And so we're just going to do exactly the same thing here. And I'll just do that off screen and then hopefully I can still find it. Okay, and so now this should work. So what we'd like to do, I'll just restart R just so that we are still there. Okay. So do we have a favorite, Laura, what's your favorite, do you have a favorite band? Simon, do you have a, Matt, does somebody have a favorite band? They can put in the chat. Steve Earle, okay. Is Steve, okay, let's try. I should have asked you this ahead of time, shouldn't I? Okay, so the function that we're going to use from the SpotifyR package is get artist audio features. Now let's see if Steve Earle is going to be here. And so what this is doing is it's going to Spotify. It's, oh, look at that. We do have Steve Earle. There we go. So sorry, I'll just save it properly. So you can notice that I just executed that without assigning it. So we'll call it Steve. We get our arrow there to say, okay, we're going to call this data Steve, and we'd expect something to show up here. So we can click now and we can have a look. And so we've got Steve Earle, and we've got a whole bunch of information about Steve. Was there a, whose example is this? Simon, was there an album that was released earlier this year? Maybe, hopefully. And so you guys, we get a whole bunch of fun features of the music. So we get a danceability, energy, key, loudness mode, speechiness. Speechiness actually is very useful. You can determine whether something is a podcast or something is rap, things like that. Valence is actually happiness. So the question in the chat, for those of you who are watching afterwards, is how does Spotify determine those metrics? I think that they have a bunch of algorithms that do that, and I don't think that those algorithms are public. And one, so just one moment. Sorry, I'll just check. Do they have it in this? No, so it's not in this data. But another bit of data that you can get is popularity. And so that's obviously that's something really interesting to know, but we don't know how Spotify is creating that popularity metric. Right. Okay. So anyway, we've got Steve now. Is he a happy sort of? How would you describe it? Are we talking depression? Are we talking sort of like sad, happy? Definitely not happy. Okay. And then Alex has Justin Bieber. Given we've got a Canadian audience, we should probably use some Justin. So we'll get some Justin. Again, oh golly, what have I copied? I am looking at the time. I'm just going to make this graph and then we'll move on. So I need to get the spelling of Justin Bieber correctly, don't I? Justin, B-E-I-B-R. Okay, so hopefully we've got some Justin here. And okay. So we're going to compare, I'll just check the chat. Yeah, exactly, quite right. So Simon in the chat is saying that you can actually download your own usage metrics, and I'll show you an example, a rather personally embarrassing example of that in a moment. So I'll just get, so we got some Justin Bieber data? Yeah, we've got some Justin Bieber data. Oh, Justin Bieber's just released a new album. Oh no, 2020. Gosh, I'm a year behind. Okay. So I'll just change this. So we've got, this time we've got Justin. I'm just copying this over from the notes that was put in the chat, that were put in the chat. Okay, so we're just making a data set. So I'll just show you what that's going to look like. We're going to, oh golly, I've forgotten to load the data tidyverse. So as I was saying, every time you want light, you need to flip the light switch. So I'm just turning on the light switch so that we can use that package tidyverse. And so we've now got a data that's got the valence of Justin Bieber's albums over time, and the same if we kept looking through it, we'd get all of the ones for Steve. And so we're just going to make a plot. And so what we're expecting is that Justin should have higher valence. So values of valence that are closer to 1 are happier. And I don't know. I'm surprised. Let's just do a quick sanity check on this. When does Justin Bieber sort of come into, so we're seeing our first Justin Bieber album around about 2009. Does this fit, Alex, does this fit with sort of what you'd be expecting? A first Bieber album around 2009? Yeah. Okay, so that, I mean, there's no necessarily reason to doubt the data. Just looks like maybe Steve Earle is a little bit happier than we were expecting. And so what we could do if so we've got points. What we could do is we could replace this with, so Simon, thanks Simon for saving me here. Simon suggested that there might be a time. We might like to throw in a smoother. Alex is also suggesting we might like to throw in a smoother. And this is where this grammar of graphics, this Ggplot's coming in, because we should, if I've done this correctly, just be able to change one line and get a whole different plot. And so we do indeed see that Simon's guess that perhaps Steve is getting a little sadder, more sad over time is doing its job. And I think Justin Bieber was recently married, right? And so maybe he's got a marriage a wedding happiness. Yeah, right. We've got 10 minutes, so I won't do the personally embarrassing thing, but of the Spotify, I'll just move on to what you might, if you've been inspired by the, yeah, that's right, James. It is in the notes, James, it is in the notes. It turns out that we would just get, my wife and I would just get homesick and listen to Australian music. All right, so I'll just spend 5 minutes on what you might like to go. So just to, so rather than starting with, look, this is how you make a matrix, this is how you do addition, what Paul and I have done is we just sort of threw you in there. We were like, hey, look, this is, if you're into political science, you could get the CES data. If you're into, Toronto, you could get some homelessness data, whatever. These are all the cool things that you could do. So I'll just go through and backfill a little bit of the knowledge that we've skipped over. So R is an open source programming language, and it's focused on statistics. But these days, people have built a whole bunch of packages around that make it far more useful for things far beyond just statistics. The packages, so we went through 3 packages today. We went through cesR, we went through Open Data Toronto, we went through SpotifyR. Packages are collections of R code. And so if we could look at the package that Paul wrote, and we could see all of the R code underneath it, but you don't have to write all of that R code yourself. You can use the code that Paul already wrote. And that's what you're doing when you're using these packages. You're using code that people have already written. There's a central repository of packages called the Comprehensive Archive Network, or CRAN. And so that was what Open Data Toronto was available on. So we were getting Open Data Toronto, a collection of code that Charlotte had written. We were getting that from CRAN. But we can also just upload our code to GitHub, and we can grab our code from there. RStudio is different to R, and what RStudio does is it sits on top of R and it makes it easier to use. So my colleague Liza Bolton, who teaches here, she has this wonderful analogy that R is the engine and RStudio is the car. And even though some of us are talented enough to sort of use the engine directly, most of us just use the car to get where we want to go from A to B. The analogy also is that maybe people like Paul can use the internet from a command line, but most of us use Chrome or Safari or something that sits on top of that to make it easier to use. So they are separate, but used together, and it's just used to make it a little bit easier. So if you've been inspired and you're into this R sort of thing, my recommendation is that you choose a project. And so on this example here, we've got the quote from this venture capitalist, and she says every December, every Christmas, she decides she wants to learn topology, and she doesn't do anything, and the same thing happens the next December. And in my experience, the easiest way to learn R is not to say that you want to learn R. It's I want to achieve a project with R. I want to download some data from the CES, and I want to see, why did people vote for Justin Trudeau last election. the great aspect of R is that there's this whole community of folks that put their data out there, and you can sort of piggyback off of their enthusiasm. I'm just trying to look in the most people I think have some association with the university. Maybe you're taking classes, so maybe you have those projects given to you. But if you don't, then one great thing about R is you've got Tidy Tuesday. And this is a weekly event where people put up data, and then the whole R community can analyze that data and put up code for how they went about it. And the great thing is that it's very specific. And so the Toronto homeless data was an example of Tidy Tuesday. You can see how other people tackle the problem, and it's kind of fun. So the Tidy Tuesday that was just released on Tuesday was about the UK's art holdings, and you could see all of this collection of what's in the art holdings. And finally, we've got a minute or so. There does happen to be a whole conference about R that's happening next Thursday. It is free to register and attend. It's going to be 24 hours of people talking about cool projects and cool things that they've done with R. And so that would be a next natural thing if you are sort of getting into it and you want to find some projects. That would be my recommendations. But I do want to just close by just saying thanks very much to Simon and Matt for having us. We just largely put together this cesR package. Paul and I just put together this cesR package to solve our own problems. And then I was worried that, maybe the CES people wouldn't like us doing things. And then they were just the most supportive folks that I've ever interacted with. And it's just been wonderful. And so now I've been able to sort of use the CES data in my own classes, and we've got some of the first years in stats have been using it this term. And so thank you very much to Simon and to Matt for having us. Really appreciate the opportunity.
Just want to add my thanks to that as well.
Thanks much for joining us, guys. That was really interesting. I really enjoyed seeing how you guys tackled that. We're getting close to an hour, so but we'll try to take a few questions. I have a couple of questions of my own, but first I'll start by asking the audience if there's any questions you can submit via chat or by verbally. Okay, so I've got one question. I'll just wait if anybody wants to submit one. But one to start. So Rohan and Paul, there's this. Most R packages are hosted on CRAN, which guarantees, I guess, a certain kind of a quality control in the background in terms of how the package is built. Do you guys have plans to get this up to CRAN, or are you satisfied keeping it on your GitHub repository for the moment?
I'd personally like to get it on CRAN. Yeah, I think, because it's like the inspiration for it really was the open data package, just because we use that so much as a student, we use that so much in class with Rohan, and I just loved the accessibility and just how easy it was to move between computers. So I really tried to style this after the open data Toronto package. So with that in mind, I would hope that, since it's styled after that, that it could become available on CRAN. Pretty much every package that I styled this after is available on CRAN. So those are some of the next steps.
And maybe I missed this. Is there a way to search through the variable labels of the CES data sets in cesR, so to look for keywords? So is there a way to sort of search for I don't know, party, and then you get the questions that have party in the variable labels, like which party did you vote for, who is the leader of the Liberal Party? Like, is there a way to do kind of keyword searches through the variables? Is that built in yet?
Nothing specifically like that. Off the top of my head, you'd have to use something like from filter from the deployer package. But that is a good suggestion. Would be interesting to build into cesR as well. Some functionality like that incorporates some sort of filtering mechanism. But right now, yeah, something like filter plus string detect or something like that would be useful. But right now, nothing like that. The closest would be the like the get question, which returns the question, but there's no real filtering built into cesR yet.
Mm-hmm.
My plan so I think we'll go for a second generation of the package and the documentation. And my plan would be to add a Shiny app alongside this, and a fairly natural, it would be fairly natural to add a search functionality within that.
So the labeled package, I think, does have the a look for function, and it does look for, it does a keyword search through a data set that is already loaded into the R workspace, and it searches through the variable label. But I like, in a way, what would be nice almost is if you could, like, without necessarily loading the data sets, sort of do like a remote search before loading it and say, okay, fine. So, you know, the question about, these questions about the economy were asked in 1984, 1988, 1993, 1997, that kind of thing. So that you could then kind of pick and choose which data sets you wanted to load. So almost if there's a way to kind of like have a conversation kind of before loading the data sets.
I think that would be possible. I think definitely be something to do with like that, as like a kind of building on the get preview, where you don't have the entire data set loaded. So what effectively you could do is, you could do a search for it, and it would search the data set and then remove it from the system, and just have it return anything that you had asked about. I think there'd definitely be a way of kind of co-opting get preview into doing that.
And then the last question that I have is, so there's no, I guess at the moment, kind of, you guys haven't built any like uniform variables over time. I guess you fiddled with the demographic economic questions from 2019 as a way of like building kind of a toy data set. Do you have any kind of work plans intended to kind of build a uniform variable through the time? Like, so, some questions are asked every question, but their variable names change. Do you have any plans like that to do that?
Tim just pointed out the camera because he was asking about that in the chat. I'd like to, yeah. That's definitely a great suggestion. And the reason it just downloads the data as it is right now is one of the things is I didn't want to, by putting my workflow into cesR, I didn't want to like implicitly direct anybody else's workflow. But as an external function to say like something like harmonize or like something like that, I think would be a great idea to do.
You'd have to be a little careful, because I mean, then you're taking a little bit, you're manipulating the raw data, so you're taking on some kind of...
Yeah. And that was one of the things that in allowing people to just get the data, I wanted to allow them to just access the data and then have it available for how they work through it. But I think as an external function that didn't interfere with the raw data itself as a download, like that didn't interfere with get CES. So if you downloaded a package or a data set, and you could still work with it as the raw data, but if you wanted to have it harmonize the variables across data sets, across waves, then an external function would be useful for doing that. Definitely something I will be looking into.
Okay, those are kind of my questions, and I'll if there's any, ask again from the audience to see if there's any questions there. Okay, so with that, then I'll say thanks again to Rohan and Paul, and thanks to everybody for attending, and posting a record of this video recording of this on lispop.ca. And stay tuned and keep in touch.